this episode, we take a very common operations task and make it feel manageable, finding the few lines that matter inside a sea of text. Modern systems generate enormous amounts of output, from logs to status messages to configuration excerpts, and beginners often assume that dealing with all that text requires either reading everything or guessing. Neither approach holds up when you are responsible for systems that change quickly and when you need to validate automation behavior under time pressure. The tool concept behind grep is simple because it is about searching text for patterns and returning only what matches, which turns noise into a focused signal. What matters for this certification is not memorizing specific switches or typing sequences, but understanding how pattern-based filtering fits into safe automation, troubleshooting, and pipeline design. When you learn to think in terms of streams, matches, and predictable filtering outcomes, you gain a skill that keeps your automation fast, your decisions grounded, and your operational risk lower. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A stream is just text flowing from one place to another, and that idea is the foundation of fast filtering. Output might be produced by an application, a monitoring agent, a build pipeline step, or a system component that is reporting status, and in many environments, the most convenient way to handle it is as a stream of lines. When you treat output as a stream, you stop thinking of it as a document you must read end to end, and you start thinking of it as a feed where you can select what matters. This selection is critical in cloud operations because logs can include many sources and many time periods in the same collection, making manual scanning inefficient and error-prone. Filtering a stream is also safer than copying and pasting chunks into random places, because copying and pasting often loses context and increases the chance of misunderstanding. An operator mindset uses stream filtering to quickly confirm what happened, what failed, or what changed, without being overwhelmed by everything that also happened. That ability to narrow focus is a practical advantage on exam questions that describe large outputs and ask you what you should pay attention to first. The core value of grep in automation is that it gives you a repeatable way to locate patterns in text, and repeatability is what turns a one-time trick into a dependable workflow. When you filter by a pattern, you are expressing your intent in a form the computer can apply consistently, which is better than relying on human eyes to spot the same thing every time. Patterns can represent error indicators, status transitions, identifiers, or any other textual signature that signals meaning, and the key is to pick patterns that map to what you are trying to validate. If you are validating that a security check ran, you look for the signature of that check, not for a vague word that appears in many unrelated lines. If you are validating that an automation step changed a specific setting, you look for the structured line that records that change, not for a general term like updated that might show up everywhere. This discipline reduces false positives, where you think something happened because a loose pattern matched, when in reality you matched an unrelated line. It also reduces false negatives, where you miss an important line because you chose a pattern that was too narrow or too brittle to match real variations. Filtering is also a safety practice because it supports validation, and validation is what keeps automation from becoming guesswork. In operations, a script often claims it succeeded, but the system logs or status output are the evidence that confirms whether the claim is true. When you can filter logs quickly, you can verify that key steps happened in the expected order, that expected success messages appear, and that unexpected warnings are absent. This matters in cloud security contexts where automation might be setting access policies, updating network rules, rotating keys, or enabling logging, because you want proof of the change, not just a hopeful message. Fast filtering also helps you detect partial failures, such as a step that started but never completed, which can happen when dependencies are missing or a service is degraded. Without filtering, partial failures are easy to miss because they are buried among routine lines. With filtering, you can quickly spot missing outcomes, repeated retries, or unexpected error signatures. A good operator uses grep-like filtering as a first-line verification tool because it is fast, consistent, and grounded in observable evidence. Pattern selection is where beginners often stumble, because they choose patterns based on what looks interesting rather than what is uniquely meaningful. A strong pattern is specific enough to identify the right event while still tolerant of harmless variations, like differences in timestamps or IDs that change each run. A weak pattern is a common word that appears in many contexts, which produces a match list so large that you are back to reading everything again. Another weak pattern is an overly exact line that depends on every space and punctuation mark staying identical, which breaks as soon as a system update changes formatting slightly. The safest approach is to anchor your patterns on stable tokens, such as a consistent event label, a known component name, or a key value fragment that reliably appears when the event occurs. You also want to think about whether the pattern can accidentally match unrelated events, because that creates the worst kind of validation mistake, where your automation appears confirmed while the evidence is actually about something else. This is why pattern thinking connects directly to regular expression discipline, because the same principle applies. Choose patterns that reflect intent and reject what you do not intend. When you practice this habit, filtering becomes a precise instrument rather than a blunt tool. There is also a difference between searching for presence and searching for absence, and both are important for safe operations. Searching for presence means confirming that an expected signal exists, like a success marker or a security check entry, and that is the most common use. Searching for absence means confirming that something did not happen, like ensuring there are no error lines, no denied access entries, or no warnings that indicate degraded behavior. Absence checks are especially useful when your automation is designed to fail safe, because a fail-safe system should avoid risky actions when conditions are uncertain, and that often shows up as a deliberate refusal message rather than a hidden failure. In cloud environments, absence checks can also help you verify that sensitive values are not being logged, because accidental exposure in logs is an operational security problem. The challenge with absence is that you must be careful about your search scope, because the absence of a match in one slice of logs does not prove absence everywhere. That is why good filtering is paired with good scoping decisions, like focusing on the relevant time window, the relevant component, and the relevant execution context. Scoping is not a typing detail, it is an operational judgment skill. Case and formatting variations are another place where filtering can produce surprises if you are not deliberate. Some systems log in uppercase, some in lowercase, some use mixed formatting, and some change styles across versions or components. If you assume the case will always be the same, you might miss critical lines and mistakenly conclude that an event never occurred. A safe operator approach is to anticipate variation and to design patterns that match the meaning rather than a single cosmetic representation. That might mean focusing on stable tokens that are unlikely to change, such as fixed event identifiers or predictable key names. It also means being cautious about patterns that rely on exact punctuation or spacing, because those details are often the first things to change when logging frameworks are updated. The exam will not require you to memorize every edge case, but it will reward the reasoning that says predictable filtering requires tolerance for harmless variation while staying strict about the parts that carry meaning. That balance is the difference between filtering that improves reliability and filtering that introduces blind spots. Another core idea is that grep-style filtering is most powerful when you treat output as part of a pipeline rather than as an isolated artifact. In many operational workflows, one step produces text that becomes the input to the next step, and filtering is how you reduce that text to only the lines that matter for the next decision. This is relevant for automation safety because it reduces the chance that downstream logic is influenced by irrelevant lines, which can happen when scripts parse loosely or assume a certain line order. Filtering can be used to isolate structured segments, extract indicators of success, or capture error signatures for tree-off, and those outputs can then drive branching decisions. In cloud security automation, this is often the difference between a pipeline that stops when a security control fails and a pipeline that continues because it never noticed the failure signal. The larger point is that filtering is not merely for human eyes, because it is also a way to shape data so that automated decisions are based on clean signals. When filtering is designed thoughtfully, it becomes a risk control that keeps noisy output from producing noisy decisions. There is an operational trade-off between filtering too early and filtering too late, and understanding that trade-off helps you avoid a common beginner mistake. Filtering too early means you discard context that you later need to explain why a match occurred, which can make troubleshooting harder. Filtering too late means you carry huge volumes of text through multiple steps, which can slow pipelines, increase storage, and raise the chance that someone misinterprets noise as signal. A balanced approach often involves keeping raw logs available for deep investigation while using filtered views for routine validation and decision-making. This aligns with how operators work under pressure, because they usually start with a filtered view to find the likely issue, then widen the view to confirm context and cause. In security contexts, retaining raw logs also supports forensic needs, while filtered views support fast detection and response. The exam mindset here is to recognize that filtering is a tool for focus, but focus should not come at the cost of losing the ability to verify the story when something goes wrong. Good automation designs preserve the ability to audit while still enabling rapid operational filtering. Filtering also interacts with the idea of determinism, meaning the same input should produce the same filtered output when the same pattern is applied. Determinism is valuable because it makes automation predictable, and predictability is what reduces operational anxiety and reduces error rates. If your filtering output changes unpredictably, you cannot confidently use it for downstream decisions, and you will be tempted to add messy exceptions that increase complexity. Deterministic filtering depends on stable patterns, stable scoping, and consistent handling of formatting differences, and those are design choices you can control. It also depends on understanding that some inputs are inherently non-deterministic, like logs that include randomized identifiers, and so your filtering must focus on stable parts of the text. When you choose stable anchors, your filter output becomes more consistent, which makes it safer to automate around. This is where beginners sometimes gain confidence quickly, because once they see how consistent filtering can be, they stop feeling like logs are chaos and start seeing them as structured signals in disguise. That shift in perception is exactly what operations demands. One common misunderstanding is assuming that a match always means the event you care about truly happened, when in reality a match is only evidence that a line contains the pattern. For example, a log line might include an error code in a context that says the error was handled, or a line might mention a failure scenario as part of a test message rather than as an actual failure. A reliable operator uses filtering as a first step, then uses contextual confirmation to interpret the meaning, often by checking nearby lines or correlating with timestamps and components. This is especially important in cloud security operations where a line that contains denied might refer to a blocked attack attempt, which is good, or it might refer to a legitimate automation action that was denied due to misconfigured permissions, which is a problem. The pattern match alone cannot tell you which one you are dealing with, so interpretation matters. This is why the title emphasizes operational filtering rather than blind matching, because operational filtering is about selecting candidates for attention, not declaring conclusions prematurely. When you keep this distinction clear, you avoid validation mistakes that are based on shallow signals rather than on verified outcomes. Another way filtering supports safe automation is by enabling quick triage, meaning you can quickly classify what kind of issue you are dealing with before deciding on a response. If filtered output shows repeated timeout indicators, you might suspect availability or performance issues rather than bad credentials. If filtered output shows parsing or format errors, you might suspect input issues rather than a service outage. If filtered output shows permission denials, you might suspect identity and access control misalignment rather than a code bug. This classification helps you choose safer responses, such as retrying only when the failure is likely transient or stopping immediately when the failure suggests a security boundary was hit. In cloud environments, safe triage prevents automation from escalating an issue by repeatedly hammering a failing dependency or repeatedly attempting an action that is being denied. The exam often tests this kind of reasoning by providing text output and asking what is most likely happening, and the correct answer frequently depends on recognizing which signals are meaningful and which are incidental. Filtering is the skill that gets you to those signals quickly without draining time and attention. Filtering also ties into data hygiene, because text output can contain sensitive details, and safe operations avoid spreading sensitive details unnecessarily. When automation pipelines pass around unfiltered logs, they increase the chance that secrets, tokens, or internal identifiers end up in places they should not be, like shared job outputs or long-term storage. A careful approach uses filtering to isolate only what is needed for validation, while avoiding the inclusion of values that are not necessary for decision-making. This is a practical security benefit because it reduces the attack surface created by log sprawl. It also improves clarity for humans because filtered output is easier to review during incident response, where you want direct signals rather than pages of irrelevant noise. Beginners sometimes assume that more information is always better, but more information can increase risk and slow down response, especially when it includes sensitive data. The safer principle is minimum necessary visibility, where you preserve raw evidence securely but use filtered views for routine operational work. This principle aligns with least privilege thinking applied to information. As you become more confident, you start to see how grep-style filtering connects to everything else you have learned about safe automation. Primitive types matter because filtered output often needs to be interpreted into typed values for decisions, and loose string handling can reintroduce silent failures. Regular expressions matter because pattern accuracy determines whether filtering is precise or misleading. Iteration matters because many workflows filter once per target or once per log source, and safe repetition depends on consistent, deterministic patterns. Parameters matter because filtering patterns and scopes often vary by environment, and those should be explicit inputs rather than hidden edits. Functions matter because filtering logic should be encapsulated so it is applied consistently, and so pattern changes do not drift across scripts. Logging matters because the signals you filter for must exist and must be stable, which encourages you to design automation that produces clear, searchable evidence. When you connect these ideas, filtering becomes more than a convenience because it becomes a core technique for making automation observable, verifiable, and safe. To bring it all together, the main skill is learning to treat text output as a stream of potential signals and using grep-like filtering to extract the specific evidence you need for validation and decision-making. When you choose patterns intentionally, scope searches appropriately, account for variation, and interpret matches in context, you prevent a large class of mistakes that come from drowning in noise or trusting shallow signals. When you use filtering as part of a pipeline mindset, you improve both speed and safety because you make downstream decisions depend on clean, relevant text rather than on chaotic output. When you balance filtering with retention of raw logs for audit and deep troubleshooting, you avoid the trap of discarding context that you later need. This is exactly the kind of operational judgment the exam is measuring, because it reflects how real automation is kept trustworthy in cloud environments where change is constant and visibility is essential. If you can filter fast without fooling yourself, you can validate automation behavior with confidence, and that confidence is built on evidence, not on hope.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.